Exponential patterns are all around us, and since we have numbering systems that allow us to easily express and manipulate very large and small numbers, it is easy to lose sight of the fact that we do not have an intuitive sense of how exponential patterns work, or even the quantities large and small numbers actually represent. To illustrate this, we can use a modification of an old story about a wise man asking for payment in grains of rice placed on a chessboard. I will propose a payment system using pennies and a chessboard, then ask you to guess the price of a number of items. A chessboard is an 8x8 grid containing a total of 64 squares. To establish the payment system, start by placing a penny on the first square, 2 on the second square, 4 on the third, and then keep doubling the number of pennies until all 64 squares are full. To express the price of an item, name the square of the chessboard that contains the number of pennies needed to buy that item. To play along, look at or name a square close to a reasonable price for the item. Note, this is not what you want it to cost, it is what somebody selling it would realistically be willing to take for it. I will list the items in fairly rapid succession because the point is to show the limits of our intuition, not demonstrate our ability to do math. The first item is a cup of coffee. Next is a new car. Now a large house in an expensive market such as New York or San Francisco. And finally, which square contains enough pennies to cover the $1.9 trillion COVID relief package passed by the US Congress in early 2021? If you are like most people, you had a pretty good sense that the value of a cup of coffee was somewhere near the beginning of the board, but things get confusing from here. Obviously, a car costs much more than a cup of coffee, and most houses cost more than most cars, but how far up the chessboard is the price of each item? Since each item moves up the board and we are talking about pennies, it is quite easy to guess squares near the end of the board for the car or the house, leaving no room to contemplate much larger values such as the recent relief bill. This doubling every square is an exponential pattern. The number of pennies on each square is easily calculated using the formula number of pennies equals 2 raised to the power of the square minus 1. Armed with this formula and a little time, it is fairly easy to find the general region of the board that equates to the cost of each item. If you are bothered by the fact that there is a range of values appropriate for each item, note that the doubling of the number of pennies on each square means that a large range of values falls within a relatively small number of squares. For example, square 9 contains $2.56, a reasonable price for a small or medium cup of plain coffee, while square 10 is $5.12, enough for a larger or fancier coffee. And square 11 is over $10, more than most people pay for coffee. The same is true for the car and the house, with a small number of squares covering the entire range of likely prices for each item. This illustrates a trade-off when discussing values on an exponential scale. These scales are good for discussing parameters that vary over large ranges, but are not as good at discriminating between items that differ by smaller amounts. This doubling pattern means that the number of pennies per square increases from less than the cost of a cup of coffee up to more than $20 million before reaching the midpoint of the chessboard, leaving plenty of space for multi-trillion-dollar values such as the rescue package. The number of pennies increases so quickly that we pass $1.9 trillion by the 49th square, leaving 15 more doublings before getting to the end of the board. In fact, the repeated doublings increase the value so quickly that the 54th square has about $9 trillion worth of pennies on it. This is more money than changes hands every year in the entire global economy. By the time we reach the end, there are over 9 times 10 to the 18 pennies piled up on the last square. This is an enormous number. In fact, it is more money than has ever existed. With a little time and math, we can come up with the right answers, but with these type of patterns, we cannot rely on our gut feelings or instincts because these patterns are beyond our normal experience. Our lack of intuition about these patterns is called the exponential growth bias. Recognizing the limits of our intuition is fundamentally important to making sense of the modern world because exponential patterns are all around us in measuring systems such as the Richter scale for earthquakes, decibel scale for sound, and the pH scale to measure acidity. They are also present in real-world phenomena such as the frequency, wavelength, and energy of different forms of electromagnetic energy, population growth, chain reactions, and feedback loops. Exponential growth bias is what causes us to underestimate the risks associated with things like the growth of interest rates on credit card debt and the uncontrolled spread of infectious diseases like COVID-19 or the measles. If you found this video helpful, please consider sharing it and giving it a thumbs up. Feel free to comment with any questions or suggestions, and if you want to keep up with the content here at Science Primer, click the subscribe button. Thank you for watching.